Bonjour. My presentation today is about the assessment of potential impacts of oil and gas development activities on shallow aquifers in the Fox Creek area, which is located in west central Alberta. I'll skip this slide for the presentation. This multidisciplinary project involves many people, mainly because it became last fall one of the few projects within the federal government to study cumulative effects. It involves research scientists from the federal and provincial governments and university professors, as well as grad students. I will only present today the work related to the EGP program, so the hydrogeological work per se is not presented here. Other components of this project, such as those related to vegetation, forest, snow cover, and wetlands, will not be presented either. The 700 square kilometer watershed that is the focus of this project is located just southwest of the town of Fox Creek. Fox Creek was selected because it is one of the most active regions for oil and gas production in Canada, and it has experienced some of the largest induced seismic events in the country related to hydraulic fracturing. The regional shallow bedrock aquifer is located in the Paskapoo Formation. This is a photo of the Paskapoo Formation. This formation is the most important groundwater supply in the province. However, in the Fox Creek area, the oil and gas industry is pretty much the only user of this resource because it is strictly an industrial area. Aquifers at the surface here in the Paleogene Paskapoo Formation, and the unit targeted by the industry here, the Devonian Duvernay Formation, are separated by what is called the intermediate zone. One of the objectives of this project is to study the intermediate zone integrity. The composition of organic matter and its thermal maturation was studied this year. The figure to the left presents the results of new vitrinate reflectance data and vintage data from the GSC database. The figure to the right presents the Rockyval TMAX data for Duvernay samples compiled from historical GSC databases. Both maturation indicators show an increase of thermal maturation from east to west, which coincides to progressive deeper conditions in that direction. The results indicate late oil window in the east to condensate and wet gas zone to the west. Gas composition with depth was also studied. The goal of this project component is to help us characterize potential sources of dissolved hydrocarbons in groundwater if some thermogenic gas is found in groundwater during fieldwork that is to come. Many graphs and indicators were explored. The graphs here show the isotopic ratios, delta 13C, of ethane and methane versus depth for a given well. The inverted trend indicates an isotopic rollover due to secondary hydrocarbon cracking in an overpressure zone, mainly due to the rollover of delta 13C values of ethane and the statistically similar delta 13C values of methane for formations extending from the Manville to the Duvernay. This will render more difficult the identification of the source or provenance from a deep-seated unit of any dissolved hydrocarbon in shallow groundwater if it were to show a thermogenic origin. Now let's talk about the geomechanical study. It aims at a better understanding of the behavior of the intermediate zone to eventually develop a geomechanical model of the entire sedimentary succession. To study fractures in deep formations that could play a major role with regards to upward fluid migration, seismic data were analyzed, among other things. Faults F1 to F7, shown on this figure using dotted lines, are generally oriented in a north-south direction and correspond to subvertical strike-slip normal faults. Colored circles on this figure represent seismic events above a magnitude of 2.5 on the Richter scale. Fault F3 was found to be very well aligned with epicenters of felt seismic events that may indicate that the induced seismicity was related to a fault reactivation. 2D deep seismic data show that faults F1 to F7 are present only below the top of the Duvernay Formation or close to, so the faults would not propagate into the intermediate zones, suggesting a good intermediate zone integrity. However, 3D seismic data could eventually reveal lateral movements and show an extent of some of these faults through the Wabamun Formation, which would have resulted from thermal dolomitization. Also, petrophysical properties were studied. This figure shows that permeability and porosity from core samples shown with dots here correlate well with estimated profiles based on existing logs from the industry. These data also show that the Duvernay Formation is characterized in its lower half, but by higher shale content and higher P and S wave velocities, which indicate more brittle rocks. And this is indeed the portion that is targeted by the industry. As well, geomechanical properties estimated from core plugs generally correlate well with estimated profiles obtained from well logs and confirm that the shale is slightly more brittle in the lower portion of the Duvernay Formation, with an increase in values of Young modulus and thus rock strength. The goal of the shallow geomechanical study is to dynamically characterize the shallow units to obtain their geomechanical properties to feed the model. Since no data were available, in situ seismic cone penetration tests and multi-channel analysis of surface wave techniques were carried out last March in the study area. Results are being processed and interpreted. This summer, we will drill 4 or 5 shallow wells to be able to sample rock and obtain porosity and permeability values from core samples. Borehole geophysical logging will probably have to be done at the same time than drilling, as rock from the Paskapoo Formation is very friable and wells need to be cased. Groundwater sampling may only take place next year due to fieldwork and budget constraints. Some of the activities that will take place this fiscal year related to fieldwork include the interpretation of borehole geophysical logging data and the definition of the local stratigraphy and an analysis of hydrocarbon composition in rocks from new monitoring wells. Thank you very much.